Hi there. In this video, I'm going to work through some factoring problems. The page here is titled Factoring Trinomials. Strictly speaking, they're not all trinomials. They don't all have three terms, but the general idea is to be able to factor quadratic expressions that look like this. And we want to try to factor these expressions as much as we can. So in this first example, notice that the value of a is the number in front of the x squared term, and here it's equal to 1. So in this case, we can simply look at the last number and try to find two numbers that multiply to equal 30 and add to equal 13. So you might have a good guess how to get started. To be systematic about it, we could think about, okay, 1 times 30 adds to 31. 2 times 15, that's not going to work. 3 times 10, that's the one. So we could start by listing all of the possible factors and keep going and list them all, or at least list them until we find the one that works. And then in this case, we can factor the expression as x plus 3 and x plus 10. To make sure that this is right, to make sure that this works, we can always check by multiplying the expression back out again. X times x is going to be x squared. X times this 10 is 10x. This 3x times x is 3x. Sorry, this 3 times x is 3x. And then finally 3 times 10 is 30. So putting these like terms together gives us the 13x that we started with. And so this is indeed the correct final answer. Because it's very friendly in some ways, you might come across this situation pretty often. This is called the difference of two squares. What I see here is the perfect square x squared, x times x, and the perfect square 16 is 4 times 4, with a minus sign in between them. So it's the difference of two squares. And this will, in general, factor as x minus 4 and x plus 4, or I should say this particular one factors as x minus 4 times x plus 4. In general, whenever you have a squared minus b squared, it factors as a plus b times a minus b. Our next example is a bit more complicated because this time the value of a is not equal to 1. The value of a equals 2. So I like to describe the technique for kind of factoring this systematically. I call it the AC method. We're going to do a little bit like we did with the first example, but instead of just thinking about 12 by itself, I'm going to multiply the value of a and the value of c. So I get 24, negative 24, and then what I'm looking for is a pair of factors that multiplies to equal negative 24 and adds to equal the value of b, positive 5. Now this time, because the product needs to be negative and the sum needs to be positive, I want the larger number to be positive. So one possibility would be 1 and 24, negative 1 and 24. Negative 2 and 12 is another, negative 3 and 8, negative 4 and 6. Well, wait a second, I could have stopped here because negative 3 and 8 are the ones that work. And again, if you quickly see the factors that you need, you don't need to list them all, but this is a way to kind of systematically think about all of the options. Because factoring is a bit of an art. Not every expression factors, and so by creating this list, if I didn't see the appropriate values on the list, it would indicate that I might not actually be able to factor the polynomial. But in this case, we ended up with negative 3 and 8, and so I can rewrite the expression as 2x squared plus 8x minus 3x minus 12. This is equivalent to the original expression because these two terms combine to create that positive 5x. And now I'm going to do a technique. I'm going to use a technique called factoring by grouping. I can factor out a positive 2x from the first two terms. It leaves behind x plus 4. And I can factor out a negative 3 from the second two terms, and it also leaves behind x plus 4. So this x plus 4 is exactly the same. That means, I have x plus 4 times 2x, x plus 4 times minus 3. I can rewrite this as 2x minus 3 times x plus 4. So one way to think about what just happened, both of these together became the common factor x plus 4. This minus sign that's in front of the 3 is kind of exactly the same as that minus sign there. So I'm taking the x plus 4 here, I'm thinking of that as a group, and x plus 4 here, and it's becoming this x plus 4. Again, with factoring, we can always check by multiplying this back out. If I take 2x times x, I get 2x squared. 2x times 4 is 8x. Negative 3 times x is minus 3x. And negative 3 times 4 is minus 12. And so there we see again, by combining these two terms, I get the original expression with 5x as that middle term. So this is the correct factorization. Problem D, in some ways, is a very simple example. We have a binomial, and the only thing I can do with this is factor out the greatest common factor. So x is a factor of x squared. It's also a factor of 10x. So what's left behind is x minus 10, and that's it. So if you have a binomial, if you only have two terms, the two options are it could be a difference of two squares, or it could perhaps have a greatest common factor. So it's always good to look for the greatest common factor of all the terms. Now, in example E, we have to be a little bit cautious. Notice that this exponent is a 3 and a 2, but then the last term is just a constant term. So it turns out we can factor this a little bit because 5 is a common factor. I can take 5 away from x cubed. 15 becomes 3 if I divide by 5, and 20 becomes 4. But that's all that we can do. This is the final answer, based on the way the problem is written. But I want to share a second possibility. So this is an alternate problem E. Let's imagine that we had an x with that last term. So as it was presented to us, initially there wasn't an x. But imagine if this was a 20x instead of just a 20. Well, in that case, we could factor out a 5x, and it would leave behind x squared minus 3x minus 4. And then we could look at this trinomial. It's a trinomial with a equal to 1. So it's kind of that simple situation. And you might notice that negative 4, we're going to get that product of negative 4 from positive 4 and negative 1. Or should I write negative 4 and positive 1? Well, I want that middle term to be negative. And so it's going to be this second option, because negative 4 plus 1 will give me a negative 3. And so my final expression, 5x is just kind of hanging out in front. I get x minus 4 and x plus 1. And again, we could double check our work by multiplying that back out to make sure it's correct. And then finally in part F, again, the value of x squared, the coefficient in front of x squared is just equal to 1. So we have that kind of simpler situation. I want a pair of numbers that multiply to equal 16 and add to equal negative 8. It turns out it's exactly the same. Since 16 is a perfect square, negative 4 times negative 4 is the pair of numbers that I need, because negative 4 times negative 4 adds to negative 8. So because it's exactly the same factor, we can combine them and then use an exponent to represent our final answer. So this is sometimes referred to as a perfect square trinomial, because it can be factored into an expression that is a perfect square. Well, I hope you enjoyed the video. Thanks for watching.